Today is the last day of Chapter 5. Just a warning, Section 5.3 Day 2 is not in the PDF notes. It's not in your textbook. Why? Because it's not even in the curriculum, but I think that's a mistake. What we are going to look at today, very quickly, are the graphs of cosecant, secant, and cotangent, the three reciprocal graphs. They are very, very important graphs. I feel this is an omission in our curriculum and in our textbook. Anything that is graphable will be addressed in calculus at any level. And so what I want to do is show you guys what these graphs look like. It is not a bonus. This is something I want you guys to look at, and I included it in the hand-in assignment that you guys will be doing. Now, it's not a really hard procedure to do. I will not take a long time to develop it. What I would challenge you guys to do is to look online. Look online, just type in a search for the graphs of these guys and take a look at them. They're really not that bad to do, even though they look kind of crazy. Now, here's how you could do it. If you wanted to know what is the graph of cosecant, first of all, that is the reciprocal to y equals sine x. So they're connected, okay? They have a lot of things that go back and forth. So what I'm going to do is I'm going to start by just graphing sine. Now, I just graphed one period. We know that this guy keeps going forever. Now, let's say I wanted to graph cosecant, and I'm just going to use this as the start. Here is how you could actually do it, and I will do the final answer in red, so it's color-coded. Number one, okay, what we are going to do is spring out of the graph of sine x and just use a couple of key values. First of all, okay, right here, and right here, which would end up being 0, pi, and 2 pi, 0, 180, and 360. That's where sine is equal to 0. Now, if you think about it, sine is 0, and you can write any number over 1. When you do its reciprocal would be 1 over 0. Now, we know this, okay? We are getting quite proficient in this area. When you are dividing by 0, it's an error, but graphically it's an asymptote, and asymptotes are something that we know will occur in graphs. The graph of cosecant will actually have asymptotes wherever its reciprocal sign has a value of 0. Now, the best way to actually look at the graph of cosecant is just to draw it and then do a brief description of it, and you guys can ponder it and Google it. If you were going to graph what is cosecant, okay, it actually looks really cool, and it's not that hard. What it does is it comes from one asymptote, goes to a height of 1, and then approaches the next. Down here would be like an upside down version, where it comes from one asymptote, goes to a height of -1, and then approaches the next asymptote. This would be one period of the graph of cosecant. Now, it keeps going. Just like sine keeps going forever and ever in both directions, so does cosecant. And again, if you type this with technology, you'd see it. There would be another asymptote, and they would keep going. There would be asymptotes here and here. And what it does is it just keeps this pattern going of coming from one asymptote, hitting a height of 1, approaching another, and then same thing, coming from one asymptote, hitting a height of -1, and this pattern would just keep going forever and ever in both directions. That is the graph of cosecant. Now, first of all, the y. Why would it look like that? Well, number one, okay, right here is where sine is a value of 1. 1 over 1. We'll do the reciprocal, it's still 1. So cosecant still has that value. Now just do this twice. If you take a look right here, okay, that little spot, sine is starting to get low. Let's say that is a height of 1/4. Right here is 1/4. Well, the reciprocal would be 4 over 1. The reciprocal has a height of 4. Right here, okay, if we take a look at this guy, this is where sine has a height of, say, -1/4. Well, its reciprocal would be -4 over 1, so -4. You can start to see where it goes in the reciprocal pattern. Now, secant can be done exactly the same. What is the reciprocal to secant? Well, it is cosine. So if we graph cosine just all by itself, it starts at a height of 1, goes down to -1, and then repeats itself, and then again, it keeps going. It keeps going forever in this direction. It keeps going forever in this direction. It's like a cousin to sine. It looks very similar, but just starts in a different place in its most basic form. You do the exact same thing. What you'd say is, if right here and right here, cosine is a value of 0, it would be 0 there, it would be 0 here. Well then, its reciprocal secant would have asymptotes then. Because if you take a 0 and flip it, it's going to be an error. And then this will not be a big surprise. The graph of secant just does the exact same pattern. No big surprise. It looks very, very similar to what cosecant does because sine and cosine look very, very similar too. Now, the one that you really is going to make a mess, I guess, is cotangent. And that's how we're going to end this lesson, and that ends all of chapter 5. So if you were going to graph for number 3 in our notes, y equals cotangent x, what we would want to start with, and I'll just do it in the middle because it's our ending idea, is we'd just start very simply, what would the graph of tangent look like? Okay, and this one, tangent, has asymptotes at pi over 2, negative pi over 2, comes from one asymptote, goes through the origin, and then it repeats itself. It would do this again. It would come from this asymptote, go through and repeat, and my curve isn't always the neatest. Again, I'll challenge you guys to search these up, and you'd see the graphs done a whole lot better than what my shaky hand can do. Now, this is the graph of y is equal to tangent x, and I have drawn 2 complete periods. You would use the exact same idea, but then something new is going to happen. Wherever the graph of tangent is equal to 0, 0 over 1, when you flip that, it becomes 1 over 0. So here's where the graphs of tangent, the 2 that I've shown you, the 2 cycles, the 2 periods are 0. What would happen is cotangent would have asymptotes there. Okay, so we hopefully feel okay with that after doing the secant and cosecant. But then here's kind of a wild one. Right at pi over 2, negative pi over 2, this spot, that is where you are dividing by 0. And it doesn't matter what the number up here is, you're dividing by 0. Now, if you think about it, flipping that upside down goes to 0 over 1. Wherever tangent was originally an error, an asymptote, that'll be those spots right there, right there, right there. That'll be, okay, where cotangent is actually equal to 0, which is really a wild connection. Then what does the graph look like? I'm just going to draw it. The graph of cotangent comes from one asymptote, goes through, and approaches the next one, and then would just, again, keep going through in the pattern that happens. It does look a little deceptive. It looks like you're just kind of flipping and moving tangent. It's not a bad way to remember it, but it's not actually true. If you take a look at just a pure reciprocal, if this right here, I'll just say it out loud, is a height of 1/2, well, its reciprocal is a height of 2. If this is a height of 1/10, well, its reciprocal is a height of 10. If this is a height of 5, its reciprocal is a height of 1/5. That kind of justifies the actual shape that it's going to unfold.